Hello all, this is Anita. Welcome to the Machine Learning video lecture series. In this video, we will understand the support vector machine in detail. So let's get started. So this is the outline of the today's video. So first we will understand what is SVM. Then we will understand some terms related to the SVM. Then types of the SVM. Then we will see how does SVM works, advantages of the SVM, then disadvantages of the SVM, and then we will see some of the applications of the SVM, that is support vector machine. So first we will understand what is the support vector machine. So support vector machine or the SVM is one of the most popular supervised learning algorithm and which is used for the classification as well as the regression problem. But mostly it is used for the classification problem. So the goal of SVM algorithm is to create a best line or the decision boundary that can segregate this n-dimensional space into the classes so that we can easily put the new data point in the correct category in the future. And this best decision boundary is called as a hyperplane. So here in this diagram you can see the goal of SVM is to create this best fit line, or we can say the decision boundary, and which segregates the point into the different classes. Now we will see some of the key terms related to the SVM. So the first key term is the support vector. So support vector is the data point or the node lying closest to the decision boundary or the hyperplane. So here you can see, so this solid line or this black solid line is called as a hyperplane. So here you can see this support vector, these two are the support vector. So here you can see these are the support vector, or we can say these are the data point which are lying closely to the decision boundary. That means these 2 points, they are closely to the this hyperplane. So that's why it is called as support vector. They are supporting for that hyperplane. So these points play a vital role in defining the decision boundary and the margin of separation. So since these two vectors, it supports the hyperplane. So that's why it is called as support vectors. Now the next one is the hyperplane. So here the hyperplane, there can be a multiple lines or the decision boundaries to segregate the classes. So here I have shown only one, but you can draw the multiple hyperplane. So our aim is to select the right hyperplane. So you can draw the multiple lines or that decision boundaries to segregate these two classes in that n-dimensional space. But we need to find out the best decision boundary, and that helps to classify this data point. So this best boundary is known as the hyperplane of the SVM. The next one is the margin. So the margin is the distance between the decision boundary and the support vector. So here you can see this blue point and the green. These two are the support vector, and margin is nothing but distance between these 2 points. So here you can see this, we have written here the maximum margin. So SVM aim is to maximize this margin to improve the generalization and reduce the overfitting. So this SVM aim is to increase this or maximize this margin. So here you can see this is the margin, this is the positive hyperplane, and this is the like negative hyperplane, and these two are the support vectors. Now we will understand the type of the SVM. So the first type is the linear SVM. So in linear SVM, uh, here this linear SVM is used for linearly separable data. So you can see in the diagram, so these data points you can separate this with the that linear SVM or that the hyperplane which is the linear. So this linear SVM is used for linearly separable data, which means if a data set can be classified into the two classes by using the straight line, single straight line. So then such a data is termed as linearly separable data, and classifier is called as a linear SVM classifier. So such a type of data you can classify with the help of the single straight line. Now the second one is the non-linear SVM. So here you can see the non-linear SVM is used for non-linearly separated data, which means if a data set cannot be classified by using a straight line, then such a data is termed as a non-linear data, and the classifier used is the non-linear SVM classifier. Now we will understand how does SVM works. So here we will understand the working of this SVM algorithm with the help of one example. So we have taken the first case as our data is linearly separable. So suppose we have a data set like this, and with these two dots, like a green dot and the blue dot, and this data set has, like we can say, it has a two feature like x1 and x2, and our task is we want a classifier that can classify this pair of x1 x2 of that coordinate either into the green or the blue category. So this is our task. So as it is a 2D space, so by just using a straight line we can easily separate these two classes. So here we can draw the multiple line as well, but our aim is to choose the right hyperplane or the right decision boundary. So here identify the right hyperplane is our choice, so that separates the two classes. So here our SVM algorithm helps to find the best fit line or the decision boundary, and this best fit line or the region is called as a hyperplane. So this line is the best fit line, it is called as hyperplane, and SVM algorithm find this closest point of the line from both the classes. So here you can see negative class and the positive class. So it finds these 2 points, and these 2 points are called as a support vector, and the distance between these support vectors and the hyperplane is called as a margin. So here our goal of this SVM is to maximize this margin, and the hyperplane with the maximum margin is called as a optimal hyperplane. So this is shown with the help of this diagram. So our aim is to find the optimal hyperplane. Now understand the second case, that is the case 2. In the case 2 we are having that data is non-linearly separable. So you can see if the data is non-linear data, so we cannot draw the single straight line. So that time for non-linear data we add the third dimensions, that is the z dimensions, and that is calculated with the help of this equation z is equal to x square plus y square. So by adding this third, we sample into like this. So here you can see after adding third dimension, our data points are look like this. So now SVM will divide the data set into the two classes. So here you can see this SVM is dividing the data into the two classes. So this SVM algorithm has a technique called as a kernel trick, and the SVM kernel is a function that takes the low dimensional input space and transform it to the higher dimensional space. That is, it convert the non-separable problems to the separable problems. So this that's why this SVM is more popular, because it converts the that non-linear data into the it classify that non-linear data. So here you can see with the help of this, so you can see here it is in the 3D space. So you can by looking it, you can see the plane parallel to this x-axis, and if we convert this into the 2D plane with z is equal to 1, so this diagram is looks like this. So here we get a circumference of the radius 1 in case of the non-linear data. Now we will see some of the advantages of the SVM. So the first one is effective in the data high dimensional spaces. So here This high dimensional data refers to the data in which number of features is larger and than the number of observations, that is the data point. So SVM perform well even when the number of feature is larger than the number of samples. The second one is the resistance to the overfitting. So SVM are less prone to the overfitting compared to the other algorithm like decision tree. So the third one is the effective in the high dimensional space. So here SVM can work well even when the training data set is small. The next one is the ability to handle the non-linear data. So this SVM can implicitly handle the non-linearly separable data by using that kernel function. So that kernel trick function we are using for handling the non-linear data. And the last one is the versatile. So SVM can be applied to both the classification and the regression problem, and that SVM kernel function, it enables the flexibility in capturing the complex relationship in the data, and this versatility makes the SVM applicable to the wide range of the tasks. Now let us understand the disadvantages of the SVM. So here the first one is the computationally intensive. So this SVM can be computationally expensive, especially when it deals with the large data set. The next one is the sensitive to the parameter tuning. So here SVM have the parameters like regularization parameter and the choice of the kernel functions. So the performance of that SVM can be sensitive to these parameters setting, and improper tuning can lead to the that suboptimal results or the longer training time. The next is the lack of probabilistic output. So here SVM provide a binary classification output and do not directly estimate the class probability. The next one is the difficulty in interpreting the complex model. So the SVM can create a complex decision boundaries, especially when using the non-linear kernels. And the last one is the scalability issue. So here SVM may face the scalability issue when applied to the extreme large data sets. So these are the disadvantages of the SVM. Now let us look at the applications of the SVM. There are widely used in various fields. This SVM includes the applications like face detection. So in bioinformatics, in the text categorization, image classifications, handwriting recognition. So here for detecting or the recognizing the that handwritten characters, and it tests against the pre-existing data. So all these are the applications of the SVM. Now take a pause here and tell me what is the intuition behind maximizing the margin in the SVM, and after done resume the video. So here that maximizing the margin, so that SVM seeks to find a decision boundary that achieves the best balance between the separating the classes and maintaining the generalization performance. So this intuition approach has made that SVM a popular choice for the classification task across the various domains. So this is all about the SVM. Thank you.